this next example, we're going to use transformations to graph the function. Okay, we've got the function y equals 6 over x minus 2 minus 3. What transformations are taking place here?
Vertical translation by 6. Oh no, horizontal translation by factor of 6.
No. This is A, if you remember.
Vertical translation.
Vertical stretch. Okay? So there's a vertical stretch by a factor of 6, right?
Yeah.
What's the 2 here do? The negative 2, I guess.
It's going to be 2 horizontal.
2 to the right, and the negative 3?
3 down.
3 down, right? So that's going to be useful as we graph this again. Okay. So again, I've chosen values of x so that 6 is divisible by those values. And that just helps to deal with any funny fractions that we would have ended up with. Okay. So if x was negative 6, we're going to transfer through each of these transformations individually. We'll start with the base function, then we'll do the vertical stretch, then we'll do the translations. Okay, so you can see what's happening point by point. So if x was negative 6, y would be negative 1 over 6. If x was negative 3, then you have negative 1 over 3, right? Negative 1, 1, 1 over 3, and 1 over 6. If I multiply those by 6, this would give me negative 6 over 6, which is just negative 1, right? That's a nice clean value. If I multiplied this value by 6, I would get negative 6 over 3, giving me negative 2, also another nice value. Multiply negative 1 by 6, you just get negative 6, and then 6, 2, and 1. Okay, so these values here already are a lot easier to translate because now you don't have to add or subtract fractions or decimals. So that was the purpose of choosing these values for x. Does that make sense? So if you're creating a table of values, it would be a good idea to look at what the value of a is and choose things that a is divisible by. Make your calculations go easier. Okay, and then if I took this point, negative 1, and did 2 to the right and 3 down, what would it become? Well, maybe not the y value anymore. I'm talking about, I have to talk about both the x and the y value.
So just add 2 to each.
So x is negative 6, but I'm adding 2 to move it 2 to the right. So it becomes, you're right, I get negative 4. And then this was my y value, and I went 3 down. So that would be negative 4 as well. Does that make sense? Recover from my confusing statement. So negative 4 would be that final point. See if I can get this one. Negative 3, 2 to the right becomes negative 1. Okay, so that's the x value. And then, what was the y value just before that? It was negative 2, and I went 3 down. So, negative 5. Okay? You guys follow what I'm doing?
Yeah.
Okay. Negative 1, 2 to the right becomes positive 1. And then the y value after the stretch was negative 6, and then 3 down. So that would be negative 9. Am I going to run out of space now? Oh, no, I won't. If I had 1 for x, that would become 2. And the y used to be 6, I minus 3, so I get 3. If x was 3, and I added 2, that would be 5. Y used to be 2, I minus 3, that becomes negative 1. And then if x is 6 and I add 2, it becomes 8. Y after the stretch is 1, minus 3 becomes negative 2. So those are the points that I want to plot.
Sure doesn't look as pretty as the ones before.
But you don't have fractions here. That's the nice thing. right? You can just plot them. Hooray! Let's do it. -4, -4 is there. Whoops. -1, -5. 1, -9. 2, 3. 5, -1. 8, -2. Uh-oh. 5, -1. Come on. Ah! 5, -1. There we go. 8, -2. Am I good now? Yeah, I'm good. Oh. What's happening now?
Oh, it's crossing.
It's crossing the axes.
You just got a different asymptote.
I've got different asymptotes.
You
What would they be?
got 2 and 3.
What would the asymptotes be? Oh man.
X or
It really does look like the one on X is 1.5 though.
Made a boo-boo here. I can see it. X is 1. I should be adding 2, so this should be 3. Oh, nice. There we go. Did I get the Y value right? 6, yeah, okay, that makes more sense. So this should be 3, 3. Oops. Man, I'm not having a good day here. There we go. Am I better now? Okay, that looks better. So the graph kind of looks like this.